as
with the system, I can't see people because that's the idea that we don't see people. So, but I see that there are people there. So I'll share my screen, and this is the screen. All right, that's the one. Now, today is a very kind of important, unusual day for us because we all are the Thrive changed offices. We are now in a big offices, a Thrive program. Our lab will be here, and this is the first day here in this office. So certain things are not quite working, certain things are different, but this is very exciting. So first, let me acknowledge our traditional owners, the Turrbal and Yugara, as the First Nations people of the land where we thrive now. We acknowledge the important role of Aboriginal and Torres Strait Islanders people play within the Thrive community. It is now my great pleasure to introduce Corinne Mandin, my colleague for as long as I remember. I don't know when was the first time we met.
Long time ago,
many conferences, many meetings, many projects which we were involved together. So I'm really, really pleased and proud that Corinne agreed to give this presentation to us today. Now, you've seen the introduction, the Corinne's CV, and I'll just highlight a few things, not to take too much time. So Corinne earned her PhD in environmental chemistry from the University of Rennes in France, and has been working on human exposure to chemicals in indoor environments, first at the French National Institute for Industrial Environment and Risk, and then at French Scientific and Technical Center for Buildings. Now, over the years, I remember Corinne giving presentations on many different topics and involvement with many different areas. So that background in environmental chemistry really brought her to very broad areas of indoor environment. She coordinated the French Indoor Air Quality Observatory and research program created by the French government in 2001. Now, some other aspects, as I said, I'm not reading all this in detail. You've seen this. She collaborates with the World Health Organization and the European Joint Research Center. She has been involved with a number of EU projects, and very importantly, she's the immediate past president of the International Society for Indoor Air Quality and Climate, and led this book, of which I also was part. So looking at this, many activities which Corinne has been involved, I see that our paths crossed many, many times. So is this the beginning? So this is the presentation Corinne will give, and I think it is the time now to pass to Corinne.
Thank you very much, Lydia, for this so kind introduction.
I'll stop sharing.
And this nice picture. So I start sharing my screen. Do you see my screen?
Yes, yes.
Is it in correct mode? Or is
no,
it shared?
No, it is not in correct mode. It shows it shows double the screen, and also now it's fine. Yes,
it's okay. Okay,
great.
Good.
So I'll turn off my video and mute, and the floor is yours.
So thank you again, Lydia, and good afternoon, dear colleagues. I'm extremely happy to be with you today, and especially if it's a new day for you because you're joining your new building. So thank you again for this invitation. Since you're starting this huge and ambitious program in Australia, the Thrive program, I've chosen to discuss today about the challenges around indoor air quality. And these challenges, this is my own vision, of course, but they are based on the experience of the French Indoor Air Quality Observatory. And I will start with sharing with you a few information about this program, this IAQ Observatory. So this is a public program funded in 2001, so more than 20 years ago, with the objective to develop research on indoor air quality. At that time in France, there was really nothing done about indoor air quality. And so the first objective was to improve knowledge on indoor air quality in buildings, but really also an important objective was to provide support to policymakers and to provide recommendation and help for professional and general public. So really to transfer this knowledge to the practitioners. And I see that it is also an important point of an important objective of the Thrive program, from knowledge to actions. So this program is supported only by public fundings, namely the Ministries of Housing, Health and Environment, and 2 French agencies, the ADEME, the Agency for Energy Savings, and the Agency for Food, Environmental and Occupational Health and Safety, the ANSES. So the main job, I would say, of this observatory is to carry out nationwide monitoring campaigns, to observe indoor air quality, and then to understand the determinants of this indoor air quality. And one specificity of this campaign is that they are based on random selection. The buildings are randomly selected to avoid any bias due to voluntary basis. So you see on this map of France, the selection of 567 dwellings for the first housing survey carried out 20 years ago. And due to this random selection, it is possible statistically to express the results at the national level for the entire building stock. So this is very powerful for the policy makers, because in a way they have a view on indoor air pollution in dwellings, in schools, in buildings, or in any other type of buildings. So the first survey was carried out, as I told you, between 2003 and 2005. The second housing survey is ongoing. Unfortunately, there is no result yet. I will not show you any result from the second one. But from the first housing survey, I will only show you this graph, these figures, that to my mind really summarize very well the topic of indoor air quality, because you see that you see the median concentration of a group of volatile organic compounds measured in the bedroom of the dwellings on the left part of the graph, and outdoor. It means on the balcony or in the garden on the right part of the graph. And this graph summarizes the topic, because you see that the indoor concentration are all over, the median concentration are all over the indoors, or over the outdoor concentration. And there are some compounds that are not detected outdoors. So indoor air pollution is really specific, different from outdoor pollution, or influenced by outdoor pollution, of course, but different. And this is really why we need to work on this topic. And so there are many results from this survey. I will not give you all the results. This is not the objective, just a few elements. And one main result is also that thanks to this monitoring in building stocks, we have distribution of indoor concentration. And you see on this slide the distribution of indoor formaldehyde in French dwellings, still for the same survey, and it helps the policymakers to decide what are the IAQ guidelines. So you see that the guidelines, the limit value of 100 microgram per cubic meter proposed by WHO was never exceeded in French dwellings. So it was decided by the French government that it is an alert value. As soon as we are exceeding 100 microgram per cubic meter of formaldehyde in buildings, this is not normal. There is a source, and this source must be found. Then this is an alert value. We need also a long-term value to help when we do monitoring. Initially, the Public Health Agency proposed a value of 10 microgram per cubic meter. This value was also proposed in California. But this value is exceeded in nearly all the dwellings in France, 86% more precisely. So the policymakers decided not to have this value as mandatory value, because this is not feasible, not technically achievable. So today in France, the mandatory guideline value that if possible, should not be exceeded for formaldehyde in buildings is 30 microgram per cubic meter, exceeded in 20% of dwellings. So you see that this knowledge of indoor air pollution helps the policymakers to set the guidelines, and then helps the professional in buildings to interpret the measurement that they are doing and to manage the buildings. We also performed nationwide monitoring campaigns in schools, because schools are not as dwellings. There are many specificities in schools, and you see a few ones on the slides. There are use of school supplies that may emit volatile organic compounds. There is a high density of furniture and a high density of occupants. And contrary to dwellings, there is daily cleaning in school buildings, so maybe a daily emission of volatile organic compounds emitted by detergents. And one last specificity is that all the school buildings are close to a road so that the children can join the school. So there is school buildings are really influenced by the outdoor air pollution. And on the top of that, we observed that these multiple sources are combined to poor air change, because when we asked the teacher if they opened the window, they told us through questionnaire that no, they don't open the window. It's because of outdoor noise, because of safety of children, because of thermal comfort issue, simply because they don't know and they forget. So for many reasons, they don't open the window. And in parallel, I don't know the situation in Australia, but in France, there is really few mechanical ventilation systems installed in school buildings. Only 1/4 of school buildings have at least one classroom equipped with a mechanical ventilation system. So it's really rare. So the schools we observed are quite poor buildings because a lot of sources and poor ventilation. So a few words about the school survey we performed between 2013 and 2017. So similarly as for dwellings, we had the list of all the school buildings in France, nearly a bit more than 52,000 school buildings, in which we did a random selection stratified on the type of schools, nursery or primary, the type of environment, and the climatic zone. The stratification allows us to go everywhere in France, to have all the categories and to be able to study the influence of the level of school, the influence of urban or rural environments. And then the number of schools, it was decided on the basis of the targets accuracy we want on the median value of VOC concentration. So it was decided to random select more than 300 schools, and 308 schools were randomly selected in France, and 2 classrooms were then randomly selected in each school. So in total, we instrumented 602 classrooms. And once again, because of this statistical random selection, we are able to express the result at the level of French school stock. So once again, I will not give you all the results, just show you a few important things. The positive, so the measurements were done during 1 week from Monday morning to Friday evening. And so the positive results we observed is that we had low nitrogen dioxide concentration below 5 microgram per cubic meter. And we also observed low VOC concentration compared to dwelling. And I will come back a bit later about this decrease of classical VOC concentration in buildings. But on the other side, we observed we had 4 critical issues that were raised. The fine particles first. All the concentration measured in the schools, in the classrooms, were above the WHO long-term guideline value, the new one published in 2021. We are a bit surprised because in schools, in classrooms, there is no combustion. We are not smoking, we're not cooking, we're not burning incense and candles. There is no fireplaces. So we were expecting lower PM2.5 concentration compared to dwellings, but no, because of the proximity of the traffic, there were high concentration of fine particle in classrooms. The second critical thing was about semi-volatile organic compounds, such as phthalates or synthetic musk. They were detected in 100% of the classrooms, so both in indoor air and in settled dust. Third point was the lack of ventilation. we have an air stuffiness index in France, and in 40% of the classrooms, this air stuffiness was showing a really poor air change rate and a really poor ventilation condition. And the 4 points, the fourth negative conclusion, I would say, was about lead. We thought lead was an old pollutant and it was not used anymore in classrooms, but in 15% of the school buildings in France, at least one classroom had still lead in paint. So it has been forbidden since a long time ago, but it's still present in the building, and it can still expose the children. And the last type of building I will focus on are the office buildings. So similarly as for schools or dwellings, there are some specificities. There is a high density of office equipment, and we know that printers, copiers, they may emit ultrafine particles, they may emit flame retardants, so specific pollution. There is daily cleaning, one early in the morning, in the evening, so emission of volatile organic compounds. And one other specificity is that in some high-rise buildings, windows cannot be opened. So indoor air quality is really depending on the mechanical ventilation system. And it's really crucial that this system is correctly maintained, correctly installed first, and maintained, and to provide a good indoor air quality. But the good thing in office building that we observed with the IAQ Observatory studies is that office buildings are more equipped with mechanical ventilation systems. They are more maintained than schools, so the indoor air quality is a bit better. And you see on this slide, so we did a nationwide survey, again, in parallel of a school survey between 2013 and 2017. The measurements were done only in one day with active sampling in 129 buildings. And you see on this slide the box plot of the concentration of volatile organic compounds. So you realize that all the median value and the average are quite low. All the medians are below 5 micrograms per cubic meter, so low pollution. Just that sometimes we have high concentration, as you can see. So a small percentage, more precisely 8% of offices were considered as polluted. In the other rooms, it was considered as low polluted. So buildings are better. I don't know if the situation is the same in Australia, but this is why we observed in France. So if I come now to the challenges that I want to share with you, the first one I identify is the monitoring, making the monitoring easier. Because one reason why indoor air quality is today poorly considered by building managers, by policymakers, is that it's not visible. It cannot be perceived by people, like noise or like outdoor pollution. We can see the car exhaust, we can see the emission by industrial plants, but we don't see the indoor air pollution, and people think that we are protected in our homes. This is our own place, so there is no pollution. So we really need to make the monitoring be more accessible and be easier. And because today we have mainly two types of measurement techniques for measuring indoor air pollution. The passive sampling first. So you see these small passive samplers that are very useful because they are small, they are passive, there is no pump, so they are very silent. We can put them easily in a classroom or in a bedroom. But on the other hand, they are not measuring many VOC. So second techniques is active sampling. With active sampling, with a pump, we are pumping air on the material, and then we analyze in the laboratory. We can measure more VOCs. It's better, but it's complicated. The pump can be noisy. You need to measure the airflow rate when the sampling is starting, to check the airflow rate when the sampling is finishing, then send to the laboratory. So these techniques are not so easy to be massively implemented in buildings. So maybe what I think is important to consider for the future is the real-time online monitoring sensor system. And you have a few examples here, not exhaustive of all what exists. There are many things. And this is really interesting to my opinion, because instead of having one concentration, one measure during 1 week in dwellings, or 1 week in the school, or 1 day in a office building, you have the evolution over time, and this evolution allows, as you can see on this graphic, to identify the main sources, the main contributing sources. Here you can see that for the measurement of ultrafine particle, cooking is more contributing than candles. So it helps also to remediate while identifying the main sources. And it allows measuring on a very long period. With classical monitoring, you cannot repeat every week or every day over a year. It would be too expensive. But with such devices, sensor system, you can measure, as you see on this graph, over 1 year, and you can see that in summer, concentration of formaldehyde here is higher than in winter. So this is really helpful. And with this big data in front of us, we have a huge amount of data that can be used to better understand indoor air pollution. So it's useful for the researcher, but it's also useful for building managers. And because with these low-cost devices, many buildings can be equipped, and you can follow remotely what indoor air pollution is and identify if in one building there is a trouble with the mechanical system or if there is a specific sources. So we are going towards smart buildings, and I will not detail more today, but Lydia worked on this topic, and I mentioned this paper about smart homes and the control of indoor air quality. And I also saw on your website the Thrive program is having a dedicated program on intelligent buildings. So this is a very important topic, to my opinion. So important for researchers, for building managers, but also for citizens, for building occupants, because with this can help with the perception of indoor air pollution. And during COVID pandemic, worldwide, some CO2 sensors were used, and with traffic light indicators, it was showing if it was turning orange or red, that windows should be open. And in schools especially, it's very useful, since schools are poorly equipped with mechanical system. Such a device based on CO2 measurements and traffic light can help the teachers to open the window, because we observed, and I told you, that sometimes they just forgot, and they just don't realize that indoor air is becoming of poor quality. So of course, everything is not perfect, and we still have some challenges with these IAQ sensors, because some remain expensive, of course, and the low-cost one, we really need to pay attention, because I don't know in Australia, but at least in Europe right now, there is no certification, no standards. So when you are buying a sensor system, you don't know if it has been tested, and some are not reliable. Some have interferences with humidity. We need to know that to date, they can only measure the VOC in total, not specifically, and we know that VOC have different health effects. So benzene is not as butane, so we don't know with such sensors the type of VOC, specific type of VOC. Contrary to equipment that we use in a lab, there is no calibration. We don't calibrate this sensor system every year, and there may be drift over time. And to illustrate this, I just showed you two graphs of tests we did in experimental chambers at CSTB, where we injected in these experimental chambers, where everything was controlled, temperature, air change rate, and relative humidity, PM 2.5 from incense burning. So the reference measurement, the reference value, were measured with a particle counter, the green, and this is the black line. I don't know if you see my mouse, the black line. And the blue, orange, and green lines are the measurements by the sensor system. So you see that they were all underestimating the real PM 2.5 concentration. And even one sensor system, the green line, did not detect the PM 2.5. So we need to pay attention to this system. And the second example is about CO2. So once again, we injected 3 concentration of CO2 in the experimental chambers during this is the red lines. And the standardized measurement was done with a Q-track. This is the dark blue line. And on the contrary to the PM 2.5 that were underestimated, here CO2 concentration is overestimated, because CO2 is not measured directly, but sometimes it's based on VOC measurements, and then it's a calculation. So the concentration was reaching 10,000 ppm. That is not possible. So it's really to show that this is full of nice perspective, these low-cost sensors, but we still need to pay attention to these devices. And we need also to pay attention about the environmental impact, because multiplying these electronic systems worldwide, if they are all out of order a few months after being installed, and we are multiplying new ones, installing new ones, this has also an environmental impact we need to keep in mind. So the second challenge, so on the one hand, I hope you see me, you still see me. So on one hand, we need to develop this monitoring, this easy monitoring to make indoor air quality be understood, but we still need to also to keep on measuring accurately, to keep on measuring the specific compounds, because indoor air quality is permanently evolving. So I show you on these slides the evolution of the median concentration in dwellings, in bedrooms, in microgram per cubic meter over the time since 2001. And you see clearly that for toluene or ethylbenzene or xylenes, we have a decrease in concentration. These organic solvents are not used anymore in consumer products. So we observe a decrease of concentration. For chlorinated compounds, such as 3-chloroethylene or tetrachloroethylene, we don't detect them anymore today in buildings. We are below, the median value is below the limit of detection. So the indoor air pollution is evolving. So I show you just now an example for France, but I can also illustrate with studies in Germany. You see on this graph the result of the measurement that were done, that were repeated from that were repeated in Germany in the same dwellings, several hundreds of dwellings. This is a very unique study. Some such studies are rare, and you see that over time, all the concentration of alkanes, of aromatics, of chlorinated hydrocarbons, they have massively decreased. And similarly to France, there is no chlorinated compounds anymore in indoor air. Terpenes is a bit different. The concentration are stable, and we will discuss this a bit later. And another example of measurement done in Germany about aldehydes. So in Germany, they also have a nationwide survey, monitoring survey called GERES, German Environmental Survey. So they do measurements in dwellings. And you see on this graphic the median concentration of aldehydes between the survey performed in 2004 and between 2004 and 2007, and then between 2013 and 2016. And for all the compounds, except formaldehyde and hexal, there was a statistically significant decrease of indoor concentration. So in a way, indoor air quality is improving. But on another side, we have new uses, new habits in our buildings, and we introduce new compounds, and we increase indoor pollution for some pollutants. For example, I give you a few examples here. We are using fluorocompact lamps to save energy, and they may emit mercury. Vaping has appeared recently, and vaping emits glycols, for example. Another example is 3D printing. So 3D printing is not only in offices, in professional buildings. It can also be used at home, and 3D printings may emit particles and other compounds. And more recently, with the COVID pandemic, we observed the massive use of disinfectant in dwellings, and we know that there could be quaternary ammonium compounds, for example. And I could cite many other substances that are for which the concentration in buildings are increasing. Terpenes, fluorinated compounds, you may have heard about PFAS in Australia as well, siloxanes, synthetic musk, pyrethroids that are used as insecticides. Because we are using more and more scented products, we are using more and more personal care products, and so these substances are increasing in our buildings. So there are existing substances for which concentration are increasing, but we also know that new substances are placed on the market. And still from this German survey, I show you this interesting example. So during this nationwide survey in Germany, they take also, they measure indoor air quality, but they also take the dust sample from the vacuum cleaner bag, and these samples are stored and frozen. And they reanalyzed recently all the set of samples from the beginning of the GERES survey at the early in 90s or early 20s years. And you clearly see that for two plasticizers, the DINCH and DEHT, the concentration were were very low in the past years, and recently they have increased because this substance was set on the market and is more and more used as a substitute of phthalates or DHP or other phthalates that are toxic for reproduction. So new substances were introduced. So indoor air pollution is permanently evolving, and we need to be able to measure this. And so I was mentioning new substances put on the market, substances for which indoor air concentration are increasing, but there are new substances that were ignored before, because today there are new techniques that are called non-targeted analysis that allow to identify all the substances in indoor air. Because in the past, when we were doing measurements, we need to know which compounds we are looking for to use the techniques able to detect these compounds. But now with this NTA, non-target analysis, we detect everything. And this allows to detect more than several thousands of substances in indoor air or in settled dust. So these techniques are still very expensive and not used. I mentioned a few studies here, but for example, in a recent study performed on settled dust, more than nearly 2,300 substances were detected in settled dust in the frame of the Norman network in Europe about emerging compounds. So this is we have a huge knowledge still to know. One slide about the nano, also the nano size, because we have some substances such as titan or gold that are not toxic when they are not in the nano side, but becoming at the nano side means becoming with a diameter below 100 nanometer. This is what we call the ultrafine particles or the nanoparticles if they are specifically introduced in building materials. So being at this size, this nano side, it gives these substances new properties and new toxicological properties. So we also need to pay attention to the nanoparticles in buildings, and due to the nanomaterials, the paints that we may use to photocatalytic paints, for example, that are used to clean the indoor air, they may emit these nanoparticles if they are removed or if you are doing works in your dwellings. And I spoke a lot about the chemicals, but we also need to mention the airborne pathogens, the new pathogens that are appearing in our life. And SARS-CoV-2 was a good example of a new pathogen. So I will not develop much more because Lydia is much more expert than me on this topic. And I just want to show you this graph from the World Economic Forum that has just been published in the Global Risk Report, new edition, and I find this graph very interesting. So this is all the global threats and the interconnection of the threats worldwide. And infectious disease, of course, is among these major threats for the humanity nowadays. The third challenge that I want to discuss with you is the need for an integrated approach. I just show you this graph from the Global Economic Forum, showing all the interconnection and the complexity of the world in which we are living. So we need to put indoor air pollution in a global frame, in a larger frame, to be able to have this integrated approach. And so we discuss a lot about indoor air quality, but we need to also to pay attention to indoor environmental quality. It's been including also thermal comfort, acoustics, lights. This is important for the health and well-being of people. And I just show you briefly an indicator, a scoring system that was developed within the frame of the ALDREN project. Developed in the collaboration with Pavel Vargotsky that you may know. So this scoring is based on measurement in buildings and the classification of each component, the thermal environment, the acoustic environment, indoor air and lights environments, and giving notes and giving at the end an overall score of the building. So it helps the building manager to know on which component to improve, is it thermal, and but also to have this overall approach, not overlooking one aspect. And another example developed in the Netherlands is a sort of scoring system that is very basic. It's not perfect, but it helps the occupants and it helps the building manager to have this full picture of the topics on the building. And speaking about energy, an integrated approach is really major, crucial for me at this moment where we have a massive energy efficient renovation plan. I don't know in Australia, I suppose it's the same as in Europe. So we need to fight against climate change. So we need to reduce our energy consumption. We need to reduce emission of greenhouse gases. So we need to reduce the consumption of buildings. Buildings have a huge part in the energy consumption worldwide. So we need to save energy, and saving energy is renovating. But if we renovate the building and we don't pay attention to indoor air quality, we can have it can become counterproductive, because you see on this graphic the measurement of radon that were done in more than 3,000 French dwellings, and all equals besides, all things equal, we observed that the concentration of radon was statistically higher in dwellings that were retrofitted compared to dwellings that were not retrofitted, because everything was made airtight, the roof, the windows, but radon is coming from the soil and is still coming after the building is retrofitted and cannot be evacuated if ventilation is not considered. And when we looked more carefully the renovation action that were done in these dwellings, we observed that ventilation was not considered a lot, was ignored in most of the situation. People are changing their windows, they're isolating the walls, they are changing the envelope insulation, but they forget to install a mechanical ventilation system. So the building is airtight, and indoor air is not air change is not renewed anymore. So that's why this can lead to increased indoor air concentration. So we really need today to work with people working on energy performance and to embark indoor air quality in the energy renovation, energy retrofit, to be sure that we are improving the building. We have an overall performance of the building, the energy performance, but also health and comfort performance. And another aspect in which we need to consider indoor air quality is the circular economy. I don't know if in Australia this is a hot topic, but in Europe, the circular economy is really discussed and really promoted. And so reusing materials and reintroducing some materials in buildings, we could lead to reintroducing some forbidden compounds, phthalates or asbestos. So we really also need to consider indoor air quality, the quality of materials when we are reusing the material from the buildings. And I also wanted to mention the context of the climate change, because this is now this is part of our world, and climate change is also influencing indoor air quality, and in many ways. You see on this graph all the connection, the influence on indoor air pollution that can be due to climate change. Climate change is higher outdoor concentration, outdoor temperature. So higher outdoor temperature means higher indoor temperature. It means higher building material emissions, so higher indoor concentration. We know that climate change will lead to higher ozone concentration outdoor, and ozone is involved in indoor reactivity. So it can lead to new VOCs or ultrafine particles in buildings. If it's warmer, we may use more air conditioning, so windows may be less open, so it may lead to increased indoor concentration if there is no mechanical system. And but on the other side, maybe it will be better, because with a warmer climate, maybe windows will be more open in winter or in other seasons. So it could lead to decreased indoor concentration. So it's a complex issue also. And so climate change is warmer temperature, but it's also more often extreme events. And extreme events is flooding that can lead to mold and dampness, wildfires that can lead to indoor particles. And we were in all parts of the world, there were recently big wildfires, and that has a major impacts on indoor and outdoor particle concentration. And when there is storm, that there is no electricity, people can use the portable generators, and they can be poisoned with carbon monoxide. So you see, indoor air quality will also involve in the near future because of this context of climate change, and this need to be considered. And the last challenges I want to discuss with you, but it will be brief, is the raise of awareness and the transfer of knowledge to building professionals. Because as you realize, the knowledge is, we still need to know more about indoor air pollutant, the connection with health. There are increasing diseases today, increasing allergy, increasing cancer in children. They can be due to pollutants that people are breathing every day in buildings. So knowledge is still needed, but at the same time, today we don't need to wait more for more research. We need to act now. We know enough to act, and we know enough to improve indoor air quality. We need to both work parallel, research still done, but also action to improve indoor air quality in buildings. And the second thing is that maybe you think it's too complex, and sometimes many buildings managers are saying, yes, it's complex, and they're afraid, they don't want to do anything. But yes, this is complex. But at the same time, we know that some remediation action are easy and are affordable. Using less cleaning products, for example, is easy, and it can improve indoor air quality. Checking the airflow rate at the mechanical ventilation system is not it's not complicated, it's affordable, and it helps identifying if the mechanical system is not functioning. So we really need to say to people building buildings, to people maintaining buildings, that it's feasible to improve indoor air quality, and it's affordable. And once again, in the Thrive program, you have I saw that you have a dedicated program to translating knowledge and innovation to the building professionals. So it's also very important. So as a conclusion, I will say that so indoor air quality is not a single topic. It's a topic in among many other environmental and societal issues. There are many research challenges still remaining. That's why research is still you will carry out many work in your Thrive program, and worldwide there are still many research done, in particular to better understand the relation between indoor pollution and health effects. Maybe we need to describe more accurately the health connection to convince policymakers that it's important to pay attention to indoor air quality. There are also some technical challenges, but at the same time, it's also an opportunity for the professional industry. It's an opportunity for innovation, and this is good. And last but not least, there are communication challenges. We really need to provide relevant information to policymakers, to architects, to all the building professionals, and to the public to make indoor air quality be known, and to make people act to improve this indoor air quality. And with the COVID-19 pandemic, it in a way it has helped raising awareness. And I just show you two pictures. This is in French, so you may not understand. But the first one on the left part is about opening the window, and it was said by the French government that it's one of the measures to remove the virus from the dwellings. Open the window. So it was the first time that at the national level there was a recommendation of opening the window, improving the air quality, because the virus is airborne. So it was not immediate after the start of the pandemic, but it was then well understood by the policymakers. And during the pandemic in Paris, there was such sign. So it means if you want to open the window for the virus, remove the virus and open your window. So I took this picture because this was really new for me, and that it was in the streets, and everybody was aware about indoor air quality and the need for air change rate. So thank you for your attention, and I'm ready for discussion now and your questions.
Thank you very much, Corinne. It was really, really excellent. You'll disappear. Oh yeah, now we can see you. It was just sort of resonating with me, just amazingly. Just before this meeting, before this presentation, we had a meeting with the Queensland Department of Education, and we are talking. We have them a partner in one of the projects, and we are talking about what research to conduct. So when you talked about the project in France, exactly the same issue, really exactly the same issue. The natural ventilation and the windows are closed. They are never open. and how to deal with this. Then the survey, which was done, concentrations of high concentration of PM2.5. This is on the one hand, it is the proximity to roads, also the dust brought by the kids. So all the issues are really the same around the world, and therefore dealing this as a global community.
Exactly.
This is extremely important. On the other hand, I'm very impressed with what has been done in France, which was never to that extent done in Australia. The surveys of the housing offices, schools, there was no work quantifying this like this. So that's something which to me is extremely impressive. And also impressive is that recommendation during the pandemic, which you are very right, pandemic brought the focus on indoor, and it's up to us now to keep that focus. Open the window. Here we still don't see this kind of stuff. Open the windows. Until recently was all the time washing hands. So so in that sense, France is much more advanced than.
It was washing hand at the beginning, but I would say maybe 6 months after the beginning, people realized that it was also in the air, and we started maybe summer 2020 having this advertisement about opening the window and using CO2 sensor in school to, as soon as the concentration was exceeding 800 ppm, they were asked to, either the children were getting out of the classroom or the windows were open. So, but as you say, we really need to keep the momentum and use this experience from the pandemic to keep attention on indoor air quality. And my feeling is that people are forgetting very rapidly, the citizens, but also the policy makers. And now, after the pandemics in Europe, we moved to the war in Ukraine, the energy troubles, and so indoor air quality is a bit disappearing from the radar. And this is this is hard to maintain this awareness and this attention on indoor air pollution.
What I'm not sure what are the questions, because in this system I'll pass to Rafat for the questions. I think we can see the question. Something which I'd like to ask is the indoor air quality standards, because the reality is that without indoor air quality standards, which are legislated, it's very difficult to do anything, because it's kind of voluntary, depending on awareness, depending on individuals. And this is something, of course, in Australia, this is non-existent. In many places now, there are some elements of this, like in Belgium, there is a standard, as I understand now, on CO2 concentrations. Are there any legislated standards in France, and is there discussion about this?
There are some standards for five pollutants, but in different contexts. There are a guideline value for asbestos. As soon as you have materials in a building with asbestos and that these materials are degraded, when you sell the buildings, you need to do measurement, and you need to check that the fibers in the air are below 5 fibers per cubic meter. So there is asbestos in a specific context. There is a guideline for radon. Radon, there is the Euratom value, and that the 300 becquerel per cubic meter must not be exceeded, but not in all buildings, only in schools, hospitals, and sanitary buildings, and measurement must be done every 10 years. So you see, it's not very frequent, but radon is not evolving so much over time. There is a guideline value for carbon monoxide. If you have a boiler at home, and if every year you're supposed to check the correct functioning, and every year you need to measure carbon monoxide. And if it's over a given guidelines, you need to repair the boiler or the combustion system. And there are 2 guidelines value for formaldehyde and benzene, only for schools, and measurement are requested as soon as there is a major work in the school, an extension of the building or the furniture is changed. So this is a new regulation since it was implemented in 2015, but it was not functioning very well because the municipalities were complaining that it's too expensive. So it was changed last year, and this regulation is still is not very well known in France and also abroad. And yeah, it's a progress, but people are complaining because it's too expensive to do monitoring. But so we have these guidelines. We have a few ones, but used in different contexts, not applying for all buildings. And so I have to say that the French government is quite active on this topic and try to push, but yeah, we are always say that it's complicated to do the measurement, it's expensive, so it's a hard job to convince people that we need to do these measurements and check the guidelines. But I agree. I agree that we need mandatory values, because if it's voluntary, nobody's doing anything. For the material emission, we have a label, a public label that 10 VOCs are the emission are limited in all the building materials in France since 2013. And before, the government proposed that it's a voluntary labeling scheme, but after 4 years, they realized that no producer put the label on the product, so they decided to make this mandatory, and it functioned quite well, because the producer they prefer having an A+ on their carpets or paints than having a C, and people are asking for A+. So I agree with you that we need. People are complaining. Sometimes we more and more regulation, but we need regulation to push to implement things.
Rafat, I just got a text message from Bronwyn Keane saying that chat is disabled and she cannot raise my hand. So that's probably the reason why we don't have hands.
No, we have questions. We have 3. There should be a Q&A section where people are putting the questions in. We already have 3 written questions.
Can you read them?
So first is from Nizes. Can the changes in the type and concentration of VOCs be attributed to the improvement of detection methods? Corinne?
Yes, this is true that this was the reason we are able to detect more and more compounds and more accurately. So this is true that the new compounds that we detect are due to new techniques, but the decrease in concentration cannot be due to a better limit of detection, because we observe a decrease. So if the limit was not evolving, we would observe nothing. So the decrease is not associated to change of limit of detection, but the new compounds that were detected are due partly to better analytical techniques. Sure.
Okay. Question actually was from Sadek. His handle name is different. Dr. Sadek. The next question is from Henry Osman, one of our postdocs. Thanks for the great talk. A lot of discussion surrounding the indoor air quality seems to focus on improved ventilation. But how important is the development of new air filtration and purification methods? Does outdoor air also need to be cleaned?
Absolutely, yeah. This is true that I discussed a lot about ventilation, but in France and worldwide, we consider there are 3 main actions. You need to reduce the emissions, so using low emission materials and reducing the use of cleaning products, improving ventilation. And the third is cleaning and filtering the air. And this is true that the air we are breathing indoors is coming from outdoors. We have more and more airtight building, but it's not totally airtight. This is the same air, and of course we need to improve outdoor air to improve indoor air quality. The particles and the nitrogen dioxide are partly due to outdoor air pollution. So this is absolutely true that we also need to improve outdoor air quality. And I was mentioning the integrated approach. Yes, we don't need to we don't need to consider that this is 2 different topics. This is one air, and indoor and outdoor. And so filtering it's expensive. That's why I don't know in Australia if it's very used, but in France, it's having supply and exhaust mechanical ventilation system with air filters. This is not used in dwellings. This is not used in schools. This is used a bit in office buildings, in cities, but this is still considered as expensive techniques. And maintenance is really needed. So filters must be cleaned or changed. And we know that maintenance is also something to improve. So, of course, the system are very performant, but on site this is not so used or not well maintained. But this is a way to improve indoor air quality, also to filter the outdoor pollution. The particles we have in schools, if we were filtering the air entering, we would improve massively the situation, because there is no indoor sources of particles in classrooms. So all the particles are coming from outdoors. But installing mechanical system in all the school buildings with filtration would be very expensive. That's why it's a long way.
Actually, on this topic, before you read the next question, talking with the Department of Education, of course, it will be expensive, but if we want to do it all at once, but if we introduce new regulations, and that's the discussion is going between experts, that really schools should have mechanical ventilation, because with natural ventilation, there's no solution to proper air quality. So in starting with, well, as soon as we can, building schools with mechanical ventilation and with proper focusing on the indoor air quality, that's really for the future. It's that's more important than the health of our children. So saying that this
exactly,
is that's the.
But we still need to, we still need to convince people that it's useful, and it's a long way to convince,
right.
To invest.
Yeah.
Because the one we are always saying is there is a benefit, an economic benefit, but the one we are paying now are not the same that we will have the benefits. That's
right.
Always what we are told. Okay, the municipality needs, okay, maybe I will save asthma, there will be less asthma crisis or less disease, but now I have to pay my system, and this is expensive. So there is still work for our community to convince the building building owners and building managers.
You read Rafa the next question, or do you see the questions?
Yes, I can see the questions. From Jennifer Lau, who would you think should have the overall control of IAQ? Department of Health, Center of Disease Control and Infrastructure, WHS regulators, etc., or a standalone agency? Getting the correct governance right will be one of the first thresholds to cross. We don't want different agencies doing different things and confusing the public.
Yeah, this is true. That this is another reason why the topic is not moving very fastly, because it's shared between many ministers. In France, it seems to be the same for you in Australia, but there is the Minister of Environment, Minister of Health, Minister of Dwellings, and they are somehow working on new buildings, and some others on old existing buildings. So this scattered responsibility makes that nobody's taking decisions. So having a unique governance, yes, it would be good, but I'm not sure it's feasible, because I would say that we need to make them work together. But at the EU level, it was also a reason why indoor air quality disappeared from the radar. It was European Commission was very active at the beginning of the at the beginning of this century, but it was pushed by the DG on health, and then the DG and other direction, other members of the Commission came, people working on buildings, people working on energy, and then they could not agree together. They did not agree together, and the topic disappeared. So, yeah, this is a good question about governance. I don't know what is the best solution. One unique agency or one unique minister would be good, but I'm not sure that it will be feasible. So I think we need to push them to work together and collaborate and take their own responsibility, and realize that it's a shared responsibility. I don't know, Lydia,
well, the same discussion, of course, it's taking place here, but we are strongly saying that it's got to be one agency, because particularly there are standards have to be issued by one agency. Then implementation would be other government agencies, but it has to be. Well, if we look at the situation in the US, indoor air is part of the EPA. Now, they don't yet have indoor air quality standards. A lot is going really in the US in this direction, but indoor air is part of the EPA. And there's logics behind this, because after all, if we are talking about standards, the standards, for example, for particulate matter, and the impact of particulate matter from outside, having different agencies dealing with the same pollutant, it wouldn't make much sense. So there is a logics for the environment, however the environment agency is called in different countries to take responsibility of this. That's what we are arguing here. But of course, another aspect we can argue this, but they have to agree to this. So that's
exactly.
That's the. Now there's one more question I can see here.
The next question is for Dr. Bronwyn-King. Hi, Corinne. What does the new French minister think about the clean indoor air and how important it is to have his support? After you answer this question, I'll enable Dr. Bronwyn-King's microphone if she wants to ask a follow-up question after you answer that question.
Yeah, thank you for the question. So cleaning, as I said, is not the main action from the ministers are pushing for reducing the sources, using products with ambitious labels, then improving the ventilation. Cleaning is not very popular, I have to say. In France, the air cleaners were not very used during the pandemic, a bit, but there is controversy because some air cleaners are based on photocatalysis or plasma. We know that they are emitting secondary products. So this is not, and some cleaners are expensive or can be noisy. So cleaning is still not popular. It's not the major subjects the government is focusing on. The governments prefer to reduce the sources, improve ventilation. And then if there is no other choice, there is no windows, there is no mechanical ventilation, there is, in the very last step, air cleaning, air purifiers can be used, but it's the very last solution. It's not on the top, it's not the first priority of deploying this air cleaning. There is also the energy aspect. People think that air cleaning, the portable devices will cost energy, so people are paying attention to energy savings. So that's why the air cleaning is not so popular in France.
I think the question was formally not about air cleaning, but clean air. I think the formulation of the question was what the I think the question now disappeared. You removed it, Rafa. The question was about the attitude of the French health minister about clean indoor air. So that's all the actions, not just air cleaners.
Okay, sorry.
Bronwyn, is there something you would like to add to this? You've got your hands.
Yeah, well, I just thought, obviously, you've got a brand new health minister. He's only been in place since the end of July, and I was just wondering how how important it is to gather his support, the support of the department, to sort of move forwards on all of the great initiatives that clearly need to happen in parallel. So that's sort of one question. If I can ask another one, the other thing is, look, I spend quite a bit of time in France, actually, and I was lucky enough to, last year, for all the meetings I had in France, I was carrying my Aranet 4 and measuring only CO2, obviously, but CO2 everywhere I went. And I was in La Défense, where there are big office buildings, and I was on the 30th floor of a big office building, and in the room, the CO2 was 480. And I have never been inside a big office building with a reading like that. And so I just love a comment around, I mean, I was surprised that building, even though it was quite a new building, it would still be, say, 10 years old. I was just wondering about the baseline problem as well in the built environment in France. Obviously, there's a massive range of buildings. You've got some ancient buildings there, very old, and then there's new. But I was surprised that this building that couldn't have been more than, say, 10 years old, it actually had excellent air quality to start with. So I found that interesting. Obviously, CO2 only, but just as a proxy, I thought that was very interesting. And I'd love your comments on that.
So about the new health minister, as you say, is quite new, and I've not heard him speaking about indoor air quality. I must say, he's focused on hospital crisis because we miss some nurses and doctors. And as far as I know, he's not looking specifically to indoor air quality, but yeah, he's quite new. So maybe he will speak later on this topic. And in La Défense, yeah, this is a quite new, recent. This is the place where there are very modern office buildings. And as I was telling, in office buildings are quite well maintained and quite well maintained, and people in La Défense, I know that there are a group of building managers that are paying attention to indoor air quality, because they think that it's a way to that people come to rent buildings. They are also showing this as an argument. You, in this office building, you will have good indoor air quality, so come in La Défense to buy your office buildings. And what we observe also is that in schools, the children, they don't complain if indoor air quality is bad, if there is smell, or but in office buildings, people are complaining, though the adults are more, we can complain as adults. Children, they cannot complain. They cannot, they are not aware of this aspect. So in office buildings, we observed in our survey that in many places, there is a specific technical a person in charge of collecting the complaints and managing the problems with indoor air quality. I don't know if it replies to your questions, but...
Well, there will be a big complaint to our facilities management. I don't know whether you can see.
Sure. Over 1,000.
1,000. That's in my new office. So it's the first day. I mean, what's the concentration in your?
And Rafat, worse, 1,200, 300. Wow.
And this is
maybe the mechanical system is not on.
Well, this is one of the most modern building on the campus, and well, I mean, by myself, Rafat is by himself in his office, so there will be lots of complaints.
Yeah. So you still have work to be done to convince people and for a better attention to indoor air quality.
Sadek has some question I can see.
Yes.
Can you read the questions, or Sadek can join? Or
I'll read the question. In general, can we say that the indoor air quality has been improved?
It has been improved on some aspects because the organic solvents, benzene, toluene, trichloroethylene, the concentration have decreased over time. This is obvious, and some old pollutants have disappeared. Asbestos is not authorized anymore in buildings. Lead is not supposed to be used since many decades. So on the one way, it has improved, but on the other way, we have introduced new pollutants and because of our new habits. We are using more and more perfumes in buildings. I don't know if you observe this in Australia, but in France, this is fashion to have fragrances in buildings, to have identity fragrances in hotels or in commercial centers. This is they are adding perfumes, so these perfumes are increasing chemical pollution, of course. And what is fashion also is perfumes to clean indoor air, but they just add another chemicals on the chemicals. They don't clean anything. So we
pollution.
And some fragrances are sold in pharmacy. So people think if it's sold in a pharmacy, it's a good quality, it's reliable. But so we also need to change our culture, because in our mind we think that when it's smelling well, it's clean, it's safe, it's healthy. But no, it's not necessarily the case. That's when the terpenes, the concentration are increasing because of all these fragrances. So we improve, but we degrade on the other side. So that's why we still need to keep our efforts.
Sadek has also another question. If the guideline was established, how much medical costs could be saved? Oh, this is Jijun's question, sorry. Another postdoc. They're sitting right next to each other.
Yeah, good question. We assessed a few years ago the cost for the society if we improve indoor air quality. We calculated that today indoor air pollution in France costs 19 billion euro per year because of the disease and the people dying, people are getting sick. So if we would improve, we would save a lot of money. We have not precisely assess the benefits of respecting the guidelines. I know that Public Health France is doing a study that will be published soon. They calculate the benefits in terms of less asthma crisis if we respect the guidelines value in schools. If based on our school survey, the school survey from the French IQ Observatory, we have the formaldehyde concentration, the CO2 concentration. They consider that, okay, if in all classrooms we respect the formaldehyde guidelines, 30 microgram per cubic meter, if in all classrooms we don't exceed 1,000 ppm of CO2, what will be the benefit in terms of health? So this is an interesting study that is not published yet, but that will be published soon and that I can share with you. Maybe such evaluation are needed to convince policymakers. If we respect the guidelines, we save thousands of asthma crises, we save X euro, X dollars of medicines. Maybe this is what the policymakers are waiting for to be convinced. But such studies are still rare. I don't know, Lydia, if you know some.
Actually, that's what we are starting now, working with economists and with some other experts, bringing input for the economists to do a kind of a major economical assessment of cost benefits. But then it cost benefits, so there are aspects of how to, on the one hand, the improvement on indoor air quality, but another part of this, the cost, how to do it. So how to improve air quality, which means what changes to the buildings. And this is more difficult because we can discuss what changes to the new buildings would be, but even this is of course a question mark. But then if we're talking about retrofitting, so this depends on the sector, depends on the building. So for doing this, such analysis, the complexity of this is quite But
I know
that's what we started.
They did it in the US. They consider that if in office building all the airflow rate at the mechanical ventilation system is respected, not exceeded. This is a study from Bill Fisk. What would be the benefit in terms of and it was billions of dollars, if I remember well.
Yeah. Gina, would you like to ask your question?
Hi, Lydia. Yeah, it's a very exciting topic and a very nice presentation. So I have a question. It's about the treatment of the indoor air pollutants. So, you mentioned about the filters. So I'm wondering, is it a filter installed in the air conditioner? And what's the problem? What's the issues currently when put forward the filters to the market?
Yeah, it was the filters in the mechanical ventilation system, the filters filtering the air coming in the buildings. And the issue is that it must be correctly maintained, and most of the times the building manager, they forget that there is filters and that the filters are not maintained, and that's why people are reluctant to install some filters, because they already know that there will be no maintenance, and that's a limitation. But this need we need to make effort and convince people that we absolutely need to filter. But I don't know if it replies to your questions. But
it replies. So it's kind of the awareness problem currently. So people still are not very aware about the indoor air quality and their health issues.
Yeah, exactly. What to observe in our study in office building is that most of the times the maintenance is subcontracted, and once a year they come to check, and people are not aware. Building owners and the occupants don't know what type of system there is in the building, if there is filters or not. So there is a huge part of raising awareness and making people being involved, because they are not involved.
Yeah. And any other problems? How the filter is working? Does it work very well to reduce the VOCs and the PM?
Regarding PM, as far as I know, there are very efficient filters that can really reduce particles coming from outdoor. Regarding VOC, this is carbon. How do you say? Yeah, carbon. No, I forgot the name in English, but it's less common filtering VOC. It's really filtering particles.
Okay, got it. Yeah, and also I have a question for Lydia.
Yeah. Gina is our former PhD student and now in China. Where are you? Back in China, Gina? Where?
Xi'an.
Xi'an, yes.
Yeah, it's the warrior terrace city.
Yes,
Yeah,
it's a very beautiful
Historic.
city.
Beautiful city, yeah.
Yes, and Lydia, so currently our ELAC, we have a new project from the ARC. So yeah, same year we will have it's a big project, and we will do considerable research. And so I'm wondering what's the project mainly focus on? It's on the building, or it's on the air conditioner, or it's on the monitoring the indoor quality?
On lots of different aspects. Maybe the best would be if we ask Rafat to send you information about our program, Strike program, and then you will see all the projects we have.
The website is nicely done, and we can learn a lot from the website. And
Okay.
yeah, it's a wonderful project. We are very excited to see the results.
Okay, I'll have a look at.
Well, thank you very much. This was really very great. As I said at the beginning of the meeting, when you talk about the schools, my immediate thought came that we should get our colleagues from the Department of Education to listen to your presentation and then work together. So when we get to that point, and in any case, would be really good if we could stay in touch. And
of course, then there is a lot of results about schools. So
similarity of the issues is such, and your experience in this expertise would be really great if you could.
With pleasure, Lydia. Thank you again for the invitation, and
thank you very much. And we will close the meeting. We exceeded slightly time, but I hope it's not a problem for most of you and for you. So you have a good night, good day, Corinne.
Yeah, my day is starting, so have a good evening, you in Australia. And thank you again for this kind invitation, and see you soon, I hope.